This is problem number 7 on the sample test problems for test number 2. An octahedron is a solid object with 8 faces as pictured below. You don't need to know any details about an octahedron to do this problem. The surface area of an octahedron in square inches can be expressed as a function of its volume in cubic inches. A. The table below gives the volumes and approximate surface areas of several octahedra. Use this data to find a power function which models the surface area of an octahedron as a function of its volume. Okay, so power function normally is y equals k times x to the p, where k and p are the unknowns that we're after. So in this case, it's the same idea. We're just going to change the letters a little bit. So here we're interested in a power function which gives you the surface area. So I'll call that thing S, surface area, as a function of its volume, k times v to the p. So that's our starting equation. And we're just going to plug some points in. We've got different values for the volume and the surface area. So let's go ahead and start with that first point. Volume is 1, surface area is around 5.719. You might not remember this as being a gift, but if the input value is a 1, then it turns out that is a gift. But even if you don't remember it, it's okay. We're just going to plug in that point. So the S value at that point, we're using this equation here. The S value is 5.719 equals K. I don't know that yet. The V value is the 1. K times 1 and raised to the P, which I also don't know. Then normally that would be one equation with two unknowns, but because 1 to any power is 1, the P goes away, and we just get K is 5.719. So that's the gift. You may or may not remember, but now we've established again that if you know that the X coordinate or the input is 1, then the other number right there must be K. Okay, and now we'll go ahead and plug in another point. We can use either point. I'll use the second one. So the second point is, let's see, the surface area is 26.546. The K value we just established is 5.719 times the V. V in this middle point here is 10 raised to the P. P is still unknown. All right, so what we're interested in doing here is solving for P. So it feels like we're going to use logs, but it's early to do it at this moment. We need to first divide by the 5.719. So we'll do this on the calculator. So we've got 26.546 divided by the 5.719. And we get that number. So I'm just going to round that to 4.64 on the paper, but we'll use the unrounded number in the calculator, 4.64. So 4.64 is equal to 10 to the P. And then we'll hit both sides with the log. Your choice whether you use common log or natural log, but in this case, because it's at 10, it feels like one of those choices is much better than the other. And I think the one we want to use is the common log. So log both sides. Log of 4.64 equals log of 10 to the P. And then only because it's a 10, log of 10 to the P is just P. So P is equal to the log of 4.64. So we just need to take the log of that answer that's in the calculator. Log of second answer. And we get a number that's quite close to 2/3. So P is roughly 0.666. Make sure I got enough sixes there. 1, 2, 3, 4 sixes. And so the next one, I guess, is 7. So you can just call it that. If you feel comfortable thinking it's a 2/3, well, you're probably right. These numbers in the bottom row of our table were all rounded. So we can call it 2/3, and ultimately don't forget to write the formula. We're after a function when all is said and done. So the formula, remember again, was S is equal to K times V to the P. We figured out the K was this 5.719 And we just figured out the V is probably 2/3. So that right there is the answer to part A. Part B, use your function to estimate the surface area of an octahedron with a volume of 50 cubic inches. So we're going to just plug in. Instead of the V, we'll put 50. 5.719 times 50 to the 2/3. Don't forget parentheses around the power. And we get around 77.6.